MOS family. It is a very popular due to the higher density of fabrication and less power dissipation occurs in this family. Now BJT, that means the bijunction transistor, is a bipolar device. That means the current flows due to the both charge carrier. Where FET, field effect transistor, is a unipolar device. That means the FET is operated only by one type of charge carrier. That's why it is called unipolar device. Now there are two types of field effect transistor. First, JFET, that means junction field effect transistor, and another that is MOSFET, metal oxide semiconductor field effect transistor. Now JFET, it is widely used in the linear circuit, but the MOSFET is mostly used in the digital circuit. There are two types of MOSFET. First, depletion mode type, and second, enhancement mode type. Now the enhancement type MOSFET is mostly used in the digital IC. So in digital IC, mostly enhancement type MOSFET is used. Now the MOS circuit does not use passive load resistance, but MOSFET is used as an active load, which require very less space in the fabrication than the resistance. Next, the logic level of MOS circuits. So already we have seen in previous topics, there are two logic states, high or low. So generally we used 0 as a low and 1 as a high. So here in this MOS family, V0 is equal to 0, that is a low level, and V1, that means high at VDD. So if it either output may be 0 or plus or VDD. Now the MOS circuit, it is not used in SSI and MSI, but it is widely used in LSI and VLSI IC, and this MOS is used in the microprocessor and the memory. Advantages of MOSFET. MOSFET IC takes less space in the IC, so the package density is increased. Second, the passive load resistance is not used as a load with MOSFET, but MOSFET itself is used as a active load, which reduce the space in the fabrication than the resistance. Third, the resistance is not used, so which reduce the power dissipation. Fourth, the MOSFET can be easily fabricated. And fifth, and is most important, high fan out. This is the most important advantage. Now there are three types of MOS family are available. First, PMOS, in which P-channel MOSFET is used. NMOS, in which N-channel MOSFET is used. And another CMOS. In this enhancement type, P or N-channel MOSFETs are used. So it is called complementary MOSFET. In short, it is called CMOS. Now the power dissipation in this CMOS is very less in compared to PMOS and NMOS type device. Therefore, CMOS device is very popular. PMOS, in this P-type channel is used. Here enhanced mode type MOSFET is used. Now this PMOS has three terminals, which is known as a drain, gate and source. Now the majority charge carrier enters through the source terminal, and this charge carrier exits through the drain terminal. Here, as shown in this the symbol of this P-channel MOSFET, the broken line is between drain and source. Now which is indicate there is no conducting channel between this drain and source terminal, and similarly the gate is also drawn away. In P-type channel, the drain source terminal is connected to the negative supply in compared to source terminal. Now let me see the PMOS inverter. So PMOS is act as a inverter circuit. So here there are two P channel MOSFETs are used, Q1 and Q2. Now this P channel MOSFET Q1 works as a active load in the circuit, and while this P channel MOSFET Q2 works as a switching transistor. Now the drain terminal of this Q1 is connected to the minus VDD supply, and the gate terminal of this Q2 transistor is used for the inputs, and the output is taken from the drain terminal of transistor Q2 to the ground. So here we will get output Y. Now when the input signal is at 0 level or it is connected to the ground, that time this MOSFET Q2 does not turn on. So the output, so that time we will get output Y is equal to minus VDD. That means high level, or you can say the logic 1. So do you understand? When this input is 0 or it is connected to the ground, the Q2 transistor remains in off condition, and your minus VDD voltage appear across the output terminal. So as a result, we will get minus VDD voltage at the output terminal. Now similarly, when the input voltage or minus VDD voltage is applied to the input terminal A, which will turn on the MOSFET Q2. So now it acts as a switch. So your plus VDD is grounded through this transistor Q2. So at that time our output becomes 0. So here you can say when we apply 1, we will get 0. When we apply 0, we will get output 1. PMOS NAND gate. The 3 input NAND gates by using PMOSFET circuit is shown in this figure. Transistor Q1, Q2 and Q3 are the input transistor. The inputs A, B, C and are given to this transistor Q1, Q2 and Q3 respectively. And this transistor or the P type MOSFET act as it works as a active loads. Now the gate terminal of this Q4 transistor is connected to the or minus 27 volt is applied to the gate of the transistor Q2, and the drain terminal of this active transistor or active load transistor is connected to the minus 13 volt supply. So now when A or B or C or any 2 or 3 inputs, all 3 inputs are at 0 level or it may be connected to the ground, that time all the transistors are in off condition. That means they are not conducting and they remain in off condition. So as a result, this VDD minus VDD voltage is appear across this output terminal. So we will get minus VDD voltage at the output terminal, or we can say that as a result our output Y becomes 1 or logic 1. Now when E, B and C both all 3 inputs are connected to the minus VDD voltage, or that means it is connected at high level or at logic 1. That time this Q1, Q2 and Q3 transistors are turned on. So your output becomes, or as a result our output Y becomes 0. So this is the circuit. It is very simple. Now let me see PMOS NOR gate. So in these types of circuit, the 3 Q1, Q2 and Q3 transistors are connected to the parallel, and input A, B and C are connected to the gate terminal of transistor Q1, Q2 and Q3 respectively. Now the output is taken from the all the drain terminal of transistor Q1 and Q2 and Q3. So that means this all drain terminals are short circuited and output is taken from this common terminal. Now this transistor Q4 or MOSFET Q4 is act as a active load. And the gate terminal of this transistor Q4 is connected to the minus 27 watt. That means minus 27 watt is applied to the gate of this transistor Q4, and the drain terminal of this transistor Q4 or active load transistor is connected to the minus 13 watt. Now when any inputs A, B or C, any inputs at logic 1 or at high, or any inputs is connected to the minus VDD, that particular transistor conducts. If A is 1, then Q1 is conducted. If B is 1, transistor Q2 is connected. If C is at 1 logic, Q3 is turned on. If both 3A, B and C all are at 1, Q1, Q2 and Q3 will turn on. So here that's why I can write any input 1 logic, any transistor conduct, and the output as a result our output Y is equal to 0. That means our output becomes 0. But when our A, B and C are at low level, or you can say at the ground level, the transistor Q1, Q2 and Q3 are not conduct. That means they are remaining off state condition. So our negative drain voltages appear across the output terminal. So we will get minus VDD voltage at the output terminal, or we can say that it is the output at logic 1.